What a pleasure it is tonight to introduce the person I called Exhibit A of the Global Explorer. Professor Claudio Piani was born in Turkey to a Peruvian mother and an Italian father, and he grew up in Indonesia and the Philippines before moving to Italy as a teenager. That says it all. After graduating from La Sapienza University in Rome with a degree in physics, and completing his 2-year mandatory military service as a weather forecaster in the Italian Air Force, Claudio studied oceanography and atmospheric sciences at the University of Washington, Seattle. He was funded there as a graduate student by a comprehensive 4-year Fulbright scholarship, attained his PhD with a thesis on 3-dimensional modeling of tropical thunderstorms. He went on to work as a postdoctoral researcher at Oxford University, working on environmental emergencies such as the ozone hole and climate change. I'm going to skip over some of this, but let's just leave it to your imagination that he's had an absolutely stellar career. Joined us at the American University in 2012. 2016 was promoted to full professor. He's been the chair of the executive committee of the Faculty Senate, chair of the Computer Sciences and Mathematics and Environmental Science Department, that's a mouthful, director of the Joy and Edward Freeman Environmental Science Research Center, and is today the Associate Dean for Educational Assessment and Institutional Research. Get this, his current research interests include bias correction of climate model output and climate change impacts on agriculture, hydrology, and evolution. Without further ado, I'm going to turn it over to my colleague and friend, Claudio Piani.
Okay, so what I wanted to address is there's been a lot of buzz in the media about the environmental impact of the quarantine, and so the issue is you've heard many times, like there's a lot of smog reduction, there's a lot of improvements in water clarity, there's a lot of improvements in animal behavior. And the question is, what I like to do, part of what I try to teach students is, can we differentiate from what is and what is not? What is actually a positive consequence of the quarantine? What is actually just all in people's heads? I mean, there's a lot of stuff going around on the internet, and I like to distinguish those two things. So where are we here in the quarantine? So Italy is moving into the possibly the 9th week of the quarantine. France is moving into the 6th. The US is going into the 5th. It's been quite a long time. I mean, the time is now starting to accumulate. It does make sense to start to look at what the effects on the environment are. And the main story is, well, has this cleared up urban smog? And so let's look at that. So there's one figure. So can we show, I took a few pictures off the web that I'd like to share with you. Okay, so this figure appeared on the BBC website. It says before and after COVID. This is the gateway to India. It's a well-known monument in New Delhi. Those of you who have been to New Delhi probably have seen this monument. And usually the situation is what you see on the left side, all covered in smog. You really don't have a lot of visibility in New Delhi at normal times. And this other picture, which actually was taken during COVID. Can we see the next shot, please? Okay. Now, this is the kind of thing that I refer to when I want to distinguish what is real from what is not real. So this is a shot that's pre-COVID. So whereas it is true, it's absolutely true that putting everybody in quarantine, getting people off the streets, it's actually is reducing the amount of pollution in cities. No, just stay on that. It is not true that when you go outside, you smell of fresh air. That's the effect of the quarantine, because that happens so many times during the year. All you need, and those of you who've been around a bit, so those of you who are my age, know that all you need is a good rain. If you go outside after a good rainstorm, you will see clean air, fresh air. You can see for kilometers. The visibility is exactly what you're seeing there. And now those of you who have been to India know that India has this thing called the monsoon. And for half of the year, there's very, very heavy rainfall. And in the breaks between one rainfall event and another, you are very likely to see this kind of visibility, right? So where does that leave us? So what questions do we answer? How do we determine, if I have to answer the question, well, what is the effect of the quarantine on on urban smog? Well, I look at other indicators, not visibility. So let's move one figure further, please, Ollie. All right. So here where it starts becoming more objective. I am looking at nitrous dioxide. That's NO2. Okay. Now, you don't have to worry about what nitrous dioxide is. It's something you don't want to inhale. That's what you have to worry about. Now, these are two shots that compare. First of all, they compare a 20-day average, not a single day. It's a 20-day average. So it's a broad average. And it's a measurement from space of the amount of NO2. Why am I interested in NO2? Because unlike other gases, NO2 only has an anthropogenic source. There's no natural source of NO2. So I'm seeing exclusively the effects of the quarantine. I'm seeing only the fact that you no longer have traffic and industrial and industries working in that area of China. And that is an absolutely objective signature. So that is extraordinary. I mean, I suspect that most of you don't look at total columns of nitrous dioxide every day, but that is an extraordinary image right there. And of course, if NO2 is decreased, then we can assume that all other pollutants have decreased as well. You can assume that carbon dioxide has decreased. You can assume that carbon monoxide, which is actually poisonous, has decreased as well. So we are absolutely seeing a drop in urban smog in various places in the world. Can we see the next figure, please? All right, so here is where there are other aspects of the problem that come into play. And this becomes very, very interesting for the COVID pandemic as well. So what you're looking at now is Europe. And that big blotch at the center is the region of Lombardy. That's the north of Italy, all right? We're still looking at nitrous dioxide because this is what everyone is looking at, because this is what is indicative of the human footprint, of the anthropogenic effect. And you see that the before and after pictures, this is taken actually in January. It's a comparison January to March. So March was something like 4 weeks into the quarantine. And that big blotch that's right there in the center in northern Italy is, well, not gone, but it's a lot less. It's ameliorated. So there's various things to say about that. So first of all, one of the reasons why that blotch appears there is not just because that's one of the most industrially developed parts of Italy, but also because you have the Alps to the north and the Apennines to the south, and they form a container for all the smog. So that's why that is a particularly vulnerable region to smog. But besides that, an average over a month takes in various kinds of weather, and they all sort of, different kinds of weather will lead to different kinds of what's referred to as atmospheric loading of these particles. So NO2 is not in a loose gas, but is usually attached to various particles. So there's a different kind of atmospheric loading. Now, why is this really an interesting problem? Why is the decrease in urban smog so important? Well, one of the questions I get is, what does this tell us? What does this tell us about the ability we have to reduce the emissions of CO2? Well, there's two parts to this. One is, of course, can we sustain a quarantine? And of course we can't. No one is thinking about a future world where we're just going to stay at home. I don't know about you, but I've had enough of quarantine. I definitely don't want to. I don't look forward to a week 7, even though apparently we're going to go till May 11 in France. So we can't think of a world where the quarantine is the standard. But we don't have to. We only need to look at a world where urban transport is reduced, where urban traffic is reduced, and that's really feasible. That means increasing public transportation. That means increasing electric personal transportation. That's not something that's very difficult. And maps like this that show you that there's certain regions where the blotch is very heavy. There's only certain places around the world where most of the emission occurs. and it occurs in the densely urbanized areas. And that's where we have the ability to make a large, to have a large impact on global warming impact. I used the word twice, right? So this is really some good news about our potential. It also has some not so good news about what areas of the globe are particularly vulnerable to COVID-19. If you're, I don't know whether you're aware or not, but a lot of the high mortality rates come from urban areas such as Lombardy and such as New York. And in fact, New York and Lombardy have a very, very large amount of urban smog. And there are some preliminary studies that associate a higher level of vulnerability to COVID in places with high degrees of smog. And this is sort of perhaps a sidetrack. Now, there's other things that have happened that people have come to me and said, well, Claudio, how about this? Have you seen, for example, I've had students tell me, pointing out that the Seine right now, the Seine, which is the river that goes through Paris, maybe I didn't need to clarify that, but the Seine has amazing water quality. It's transparent these days. It's wonderful. And I'd like to point out that whatever it is having in road traffic, change in road traffic, is not going to have any effects on Seine water clarity. And also, you don't look for water clarity, particular water clarity in the Seine. And also, water clarity in the Seine doesn't really depend on traffic in Paris. It mostly depends on precipitation regimes. If it rains a lot, then a lot of water comes in the Seine, it gets murky. If it doesn't rain, the Seine flows a lot slower, and the deposits have time to the suspended material, particulates, have time to deposit to the bottom. Now, point in case, let's look at Venice, because a lot of the hype was around the canals of Venice, and this is a wonderful time to, well, no, you can't go to Venice right now because you can't leave your house, but it's a particular time for Venice. So here's a dolphin in the Venice canals. Now, this is extraordinary, but it's not so much extraordinary because there is a dolphin in the Venice canals. It's extraordinary because you see a dolphin in the Venice canals. Now, the Venice canals, if you've ever been to Venice, the Venice canals are always extraordinarily murky. So it's just brown water. You cannot see anywhere. If you're in Venice, it's always brown water. And there's this usual sort of assumption that murky water is associated with a worse quality with a worse water quality. And of course, and that's not necessarily true. In fact, it's not true at all. The murky color of water can just be, it's just be lime or clay or light mud that's brought up from the bottom. And it will increase if there's turbulence in the water or in the river Seine, if the water just travels quicker, the level of murkiness will increase. And not only that, but unbeknownst to most people, it is not uncommon to have dolphins in the Venice Lagoon. It's uncommon to see them because the water is very murky, but it's not uncommon to have them. The Venice Lagoon has an acceptable level of water quality and has an extremely rich fauna. There are lots of fish in the Venice Lagoon. And if you are a marine mammal that lives on fish, the Venice Lagoon might be a place where you want to go. Can we see the next figure now? Okay, now this is where things are absolutely extraordinary. So this level of clarity in a lagoon in the Venice Lagoon is absolutely absurd. I've never seen it. I doubt anyone has ever seen it. And what I mean by anyone, I doubt anyone in the past 200-300 years has ever seen this. Now, look at the image on your, I'm hoping it's on your right, the one where you can actually see the fish. There's one where you can see a boat and one where you can see fish. I don't know which is left or right view because I have different left and rights on my phone or on the figure and on the screen. But there's a figure with actual fish, and they're not very large fish, but you understand, I hope you can guess or intuit that the fish that you see are not there only because suddenly now the canal has high water clarity. Please don't confuse the word water clarity with water quality. So that canal right now has very high water clarity, and you see the fish. But those fish, that community in environmental science, we talk about a community of organisms. So that's a community of fish. They are always there. They're always present. They live there because there's a huge amount of nutrients coming in from, I forget the name of the river, but there's a huge amount of nutrients coming into the Venetian Lagoon. And so of course there's a lot of those nutrients support a very, very healthy community of phytoplankton, which of course supports a healthy community of fish, which accepts a healthy community of predatory fish, among which also, well, predatory fish and mammals, among which also dolphins. Now the question is that water that's so transparent, what's the water quality there? And here's where you actually have to ask yourself, what determines water quality? And water quality is determined by the presence of things like phosphates, nitrates, and unfortunately, in all the coastal waters of Europe, also heavy metals, which are the worst kind of thing. Heavy metals are really a very bad thing in the water. And for example, when it rains in the Seine, you'll have the water, when it clears off the streets and goes directly into the Seine, you will have spikes in the amount of heavy metals in the Seine. And when it rains in Venice, that water washes off the streets, and it takes the debris from the oil that comes from cars and washes it into the lagoon, and there you have spikes in heavy metals. But the heavy metals and the phosphates and the nitrates don't decrease the water clarity. So that water is no less or more, the quality in that water is not less or more, is not better or worse than when it's murky, but it's not necessarily very good. So phosphates and nitrates come from farms and from cows and pigs and livestock. And that's a running problem in Europe. So in Europe, we have very high levels of fertilization and very high levels of, it's called nitrate leaching. The word is leaching when fertilizers and nitrates go into, are you asking a question, Mary?
I'm waiting for a pause. There are several questions here I want to throw at you.
Oh, go on, please. I feel very lonely right now. So.
Yeah, how quickly did we get to this level of clarity and quality, and how quickly could we expect it to go back to its normal self? That's one question. Another one is, so we are supposed to, can we conclude that air pollution and sea pollution wouldn't improve after confinement? And another question is, it's moving a little bit, sorry. If unclear clarity doesn't equate to poor quality, then does clear water equate to good quality? So it's really about the difference between quality and clarity in the water, which you're talking about. Maybe just speak a little bit more about that.
Okay, so those are three things. I can answer the first quickly. So for the deposit to come down the lagoon, it just takes 1 or 2 days, just 1 or 2 days. So that clarity right there is due to the fact that no one's driving motorboats around the lagoons. Those canals are very shallow. They're 2-3 meters of depth. Once you run through with a motorboat or even with a gondola, you're going to pick up debris from the bottom. So the second there's traffic in there, you'll go immediately back to murky water. Also, if you stop traffic for 2 or 3 days, you'll go back to that kind of clarity. It's really, really very quick. Also, as far as urban smog, yes, just like it takes 1 day of rain to wash away the smog, and for that afternoon, you smell wonderful clean air, it just takes 1 day of the traffic back and you're back to square one. So there will be no permanent effects or very little permanent effects of the quarantine. If you're thinking about greenhouse gas loading and global warming, there will be a very, very little effect, almost dismissible effect of the quarantine on that. That's not how we go forward. We need to go forward with a permanent and radical decrease of urban traffic. The other question was water quality and water clarity. No, water clarity is a necessary condition for water quality if you're thinking about drinking water. So if you're thinking of water you have to drink, then clarity is a necessary condition, not sufficient. Water has to be clear, so there's nothing floating in it. What's the word? Suspended. There's no suspensions in the water. You need that for it to be drinking quality. But then you also have to check for other things. So many times a concentration of E. coli and bacteria is sufficient to make you ill. Is something you won't be able to see. But if you're thinking of water quality in terms of the quality for an ecosystem, then the Amazon River is murky in many places and it's absolutely sound. It's a sound ecosystem. The Seine doesn't need to be transparent to be a sound ecosystem. All the water that runs off glaciers is very silty and is absolutely pristine, but you don't see through it because it's full of glacial silt. So clarity does not equate to water quality. But if you're thinking, because I'm assuming a lot of people are thinking of drinking water, if you're thinking of drinking water, then clarity is a necessary attribute. You have to have clarity because no one wants to drink, suspensions or suspended material. And then beyond that, you have to move beyond that. And I talked about heavy metals. This is one thing that's actually really problematic when you talk about water quality, because very, very, very small amounts of suspended heavy metals can be very damaging to an ecosystem. And maybe you've heard this word before in the glory days of your high school or middle school or elementary school, there's something called biomagnification. So as you move up the trophic levels, which means, the little fish eat the big fish, the big fish eat the little fish, bigger fish eat the middle fish, you go up some people might refer to as the food chain if you were in school in the 60s. So as you move up the food chain, I've upset half of my audience here, I hope not. But the heavy metals tend to concentrate more and more in the livers of living organisms or in the tissues of living organisms as you move up the food chain. This means that if you live near a bay and you go fishing and you fish something that's at the top of the tropic level, those fish may have very high concentrations of contaminants in their tissues, even if the water has a very small concentration. It's called biomagnification. It's why we are very, very worried and need to be very, very careful about the amount of contaminants in our water. That's why, for example, even though there's a very good water quality in the Venice Lagoon, we don't grow mussels in the Venice Lagoon. We grow them outside. In fact, outside the Venice Lagoon in the Adriatic Sea, there are many mussel farms, right? But you don't grow mussel farms in the lagoon.
Move on. The sort of summary comment then would be to say, do we understand then that the quarantine has not really made any effect on decreasing pollution, but maybe it's made people aware of ecology?
The quarantine has had, so I'm gonna be nuanced here and maybe annoy everyone with too much detail. So the quarantine has had an effect on pollution. It has decreased the amount of urban smog. It means that for the 7 weeks that we've been shut doors, the air in our city has been wonderfully clean. It's like having one long day after a spring shower. So it's had a wonderful effect on urban smog. Absolutely, yes. But we're talking about urban pollution. But if you take further and you're asking about mitigating global warming, which is what everyone comes to me for, because I'm a climate scientist, so I hear that question a lot. What has it done for mitigating global warming? It hasn't done a lot for mitigating global warming. But what it has done is that it has shown us the potential, the extraordinary potential that that any kind of policy or any kind of change of behavior that we take that can reduce the amount of use we make of personal transport in cities can have an enormous effect on our well-being. Enormous effect on our well-being. And also that we don't need to curtail traffic everywhere. We just need to curtail it in heavily populated, dense urban areas. And that can already have an enormous effect. So that's what it's shown us. It's shown us the potential we have to reduce, to mitigate greenhouse gas loading. If that doesn't mean anything to you, then let's just call it in general global warming. So this has shown what potential we have. But to those who think that we've created a new golden age, unfortunately not. As soon as we go back to our cars, we're right back to square one, especially in places, I don't know where everyone lives here, but there are some places who have emergencies, have urban smog emergencies, and not because they have a particularly strong traffic, but because of their surroundings. So New Delhi is right up against the Himalayas. Milan is surrounded by the Alps to the north and the Apennines to the south. Mexico City is in a ring of orography, of volcanic origin. Certain places are really set up to suffer from urban smog, because Paris is not that bad. Paris is in a slight depression surrounded by some moderate hills. So Paris has a problem of smog when you have a few days of no wind, which happens if you want to get a bit techie, high pressure, summer high pressure, those beautiful days. By the second, third day of wonderful weather, it starts to become awful and smoggy. So it's not something you really wish for. But now we've had 3 or 4 days of no wind, and it's still beautiful over Paris, and that's definitely because of the quarantine. Okay, I dare move on now. I love your questions. Please keep it going. But I'm going to go up to the next slide. So here's another one that was really curious and funny. Holly, if we can. All right. So invasion of deer. I love this one. So many places have seen unprecedented or anomalous. Let's call it anomalous, not unprecedented, but anomalous effect on wildlife. So in Europe, foxes and in the States, raccoons are moving into cities. In Britain, there's a lot more sighting of foxes, but there are some just really very, very glamorous cases or shocking cases of invasion by non-urban species. The fox is an urban species, but these are deer, and they're moving into this town in Japan. And what's happening there? What's happening is that there's a park or national reserve outside this town that usually has a huge inflow of tourists. And the tourists are part of the ecosystem. We tend to think of tourists or humans as, oh, wherever they go, we disrupt the ecosystem. We're a damaging effect. But in fact, we are not. And I always try when I teach environmental sciences, I try to sort of debunk this myth of the pristine ecosystem. There's no such thing as a pristine ecosystem. There are ecosystems that are undergoing either very, very significant disruption or mild disruption, but they're all being in some way transformed. And humans are a part of that ecosystem. So in this case, when that flow of tourists that was in that national park that actually brought food into that national park, when that flow of tourists died out because of the travel restrictions, these deer moved into the city. And they move into the city for 2 reasons. The first one is because of the lack of a source of nutrition where the tourist flow was stopped, but also because the urban area right now is a very different place. There is no traffic, there's no movement. It's a human empty environment. The urban environment is a lot less threatening. And it takes only 1 or 2 days of a less threatening environment for species to move in. And a lot of species are very much accustomed to the urban environment. And in fact, when we talk about this, we talk about what other species are accustomed to. Let's go to my last figure. And this is picture. This is actually rather interesting because it comes to a shock to many people. So these are long-tailed macaques. And that's a mouthful. They're monkeys, all right? I'll just throw in there, the difference between a monkey and an ape is a monkey has a tail. So these are long-tailed macaques. They're in Thailand, and they are invading cities, and they are very, very aggressive. So they're actually a problem. So it is unsafe for you to be out there with an invasion of that kind. And that invasion of monkeys is due to the fact that even in Thailand, you've had a complete drop of tourism. And it was the tourists that were a substantial, perhaps the principal source of nutrition for that community of macaques. And once that source of nutrition has disappeared, then that community reacts to a disruption and they invade cities and they are looking for that source of nutrition who has disappeared. Now, this case is symptomatic. It's made news headlines all over the world. It's actually rather dangerous because these are very aggressive. These are aggressive monkeys. They will bite you. They will steal. They will grab you. But we have had similar cases everywhere in Europe. So one of the things that happens in Europe on a regular basis is when you close down markets. Yeah, when you close down what in the States is called a farmer's market, and in most of Europe is just called a market, the one community you disrupt are the rats. So, for example, now all the weekly markets or the weekly markets of fresh produce are shut down, and you have communities of rats that are coming out, just wondering where this source of food has gone to, because it has literally disappeared. When in London, sometime I think 20 or 15 years ago, they temporarily closed Covent Market. If you are from London or European, you've heard of Covent Market. There was a massive exodus of rats and the die of rats from that area. It was actually quite impressive and scary to be there at that time. So the idea that we sort of live in that the human environment, the urban environment, is an environment where animals don't live, that it's not shared with other species, is really an illusion we have. The idea that there are environments outside the sea that are pristine, where humans don't play a role, is an illusion we have. And these effects, and the invasion of monkeys, the sea deer in Japan, the sightings of foxes in London, these are all sort of things that show us that in fact we are in continuous interaction with these other communities, these non-human communities, and a disruption in our behavior produce a disruption in their behavior. And of course, the last thing I want to conclude on, this also shows us how quickly these communities react to a change in our behavior. So whereas these behaviors, these changes here are disruptive, they are negative. Being invaded by long-tailed macaques is definitely not a good thing. An invasion by deer is not a good thing. It's a reaction to stress. But it shows us how quickly non-human communities will react to our change in behavior. I'm going to stop there. I feel I'm talking to avoid again, but any questions? But
okay.
I'm done. Thank you.
Got a couple here. And then if people want to ask more, by all means, we have about 20 more minutes. So first of all, where do the rats and the pigeons, which are also everywhere, someone comments, where do the monkeys and or the rats go? They just come in and look for food and hang around? Like where?
Wait. So those are two different things. So the rat question and the monkey question have different answers.
Okay.
So there's a huge community of monkeys that always lives in and around these touristic towns in Thailand. We're talking about Thailand. These monkeys aren't coming for you unless you live in Thailand. All right. So they live around in communities around big cities and close to tourist areas. That's where they've always lived. And wherever it is they used to be, they sort of gain equilibrium. So the communities grow to the point where the communities can be sustained by the amount of nutrition or resources provided to them by, in this case, tourists. As far as the rats go, in most urban areas, and anyone from Paris, London, or New York can tell you, you are in Paris, you are never more than 5 meters away from a rat, right? Maybe that's what I've been told. But maybe you're never more than 50 meters from a rat. But you're never very far away from a rat. The rats are everywhere. Normally, they are underground or they're in places where you can't see them. Yeah? But the rats, you're always being seen by a rat. They are everywhere. And they are not generally a threat to humans. The presence of a huge rat community is not in general a threat to humans. You can have some moments where there's nothing particularly negative or horrible about a rat or a pigeon. They are communities that live within the urban area. In certain places, they're being displaced. Like in many towns close to the sea, seagulls are moving in. In many cities in Europe, parakeets are moving in because they're coming in from people taking the pets and they're escaping and they're establishing themselves. In the sand, turtles are establishing themselves. So there's nothing particularly negative about a rat community. But it does become a problem if the communities are disrupted. If a large rat community suddenly flourishes because there's a market close by or a dump close by or yes, mostly a dump that's not being taken care of by the city officials, then when that dump is removed, then you have a problem. But it's a transitory problem. So the rats are always with us. The monkeys live outside the city limits.
So nothing, these are just bringing them out to light. This isn't a learning, this isn't something we should learn from the fact that we're now seeing them because they're out in the open more than they were a month ago.
These have always been there. If anything we should learn is we should realize that we as humans, that there's a lot of non-human communities. When I say community, I use the term in the scientific way, which means groups of living creatures of one species. So the group of monkeys, of long-tailed macaques in that city in Thailand is a community of macaques. There are communities that are not human that live in equilibrium with us everywhere you are. And there's pigeons, seagulls, parakeets, turtles in the Seine, carps in the Seine, rats, and not to talk about all the green communities, the trees, the grasses, the bamboo.
What's your biggest takeaway from this? What can we learn? So we've had this moment. It obviously has shown us how easily we can turn around urban transportation caused pollution. What are some other?
So that's the biggest thing that I wanted. So that's the biggest thing I think that I wanted to come out with this talk is that what this has shown us is the potential. So certainly, we often talk about what is a post-COVID-19 world going to be like, and I don't know about you guys, but when I come out of here, I want to go out every night to a different restaurant for a month straight. But we've realized that there's a lot of activities that we can do online. I know everyone right now hates the idea of doing activities online, but some of the things we don't do online, some of the things we travel for can be done online. But also a lot more things that we didn't think we had time for, we can do online. And we've grown accustomed to doing them online. And we've grown familiar with the technique online, and we know how to use them online. So maybe we can come out of this with a slight reduction to our need to transport and move around. Also, we are now understanding what an enormous benefit this is to our way of life. Because if we can reduce the amount of urban smog by increasing how much we telecommute, by increasing how much we reduce the smog in a city, or even in local moments. So imagine when in Paris we've always had not lockdowns, but we've always had mandatory reductions in traffic when there's an emergency smog. There's a term in French I don't remember, but we have alerts. And suddenly only cars with a even license plate or odd license plate can circulate. But after 7 months of quarantine, we are trained to work in a shutdown, and we can, those kinds of reductions in traffic are not something that we'll find challenging ever again. So we could increase or increase the amount of time that we go on this kind of shutdown just to decrease the smog. We could lower the threshold that we tolerate of urban smog to do this, and that is no longer a standalone event. That becomes sort of a general change in our behavior. That becomes a standing change in policy, and that's a long-term effect. And since we see that there are only specific places that require a dire change in behavior, and there are these high-density urban areas, and high-density urban areas are places where we can actually reduce the output of smog significantly, not just because we're thinking about global warming, but because we are really thinking about our personal health. Now, let's just momentarily in all this go back to a slightly dark place. There are one of the results from early sort of COVID-19 research is that urban smog really increases your vulnerability to COVID-19. Having lived in a place like Milan for 20 years really increases your vulnerability to COVID-19. This gives you an idea. It's not a problem that has been created by COVID-19. COVID-19 is just something that uncovered an effect on you of urban smog, because you'll be vulnerable to this, but you're vulnerable to all other respiratory conditions. This is something people have known for ages. Living in a high smog environment like New Delhi, like Milan, Mexico City, will increase your vulnerability to all sorts of respiratory conditions. Everyone has known about this, but now COVID-19 has brought this to the forefront. And so we know what we are capable of in terms of reducing this threat from urban smog. So I would hope that after 7 weeks in this condition and just being able to enjoy 7 weeks of Paris as if it just rained will give people an idea of what we could have, what kind of city we could be living in, what Mexico City could look like all the time.
So that leads perfectly into a wonderful comment on exactly Milan from Tasia, who says, I read that Milan is going to make most of its city center pedestrianized after the pandemic because some research linking urban pollution and the higher risk of severe COVID-19 symptoms. If other major urban areas were to do this, will this have an effect on global warming and negative climate changes? It sounds like you would say yes to that.
I would say yes to that, because now we are no longer talking about a 5-week trend, but we are not talking about a permanent stop. And of course, what happens? That in those centers where it's a pedestrian area, I imagine you'll still be able to get around on a bicycle. Milan is nicely flat, so it actually works very well. One of the reasons why smog is such a big problem is because it's a flat area surrounded by mountains. But yes, Milan, once you establish a larger pedestrian island, and that's what's happening in Paris, sort of the mayor of Paris is trying to slowly edge out more and more areas that it tries to move traffic out of. You know, it increases the bike lane. The bike lanes are enormous now. It's like a highway on a bicycle. I go to work on non-CO2 emitting means every day, and it's a highway, and it's becoming a bigger highway, and it's just wonderful. And bikes travel. Now we have electric bicycles which go very, very fast. And we're all moving towards a zero emission kind of transportation, and that is a permanent change. And in fact, it's not so much being susceptible to COVID symptoms, but it really is susceptible to COVID mortality. I mean, you really lower. If you look at what's happened to Milan, Milan has taken so much longer to recover than any other part of Europe. If you look at the curves in Spain, they just spike and drop down. Milan is taking forever. It's going down very, very slowly. So I think people right now, so I mean, one of the things, I remember this sentence from Obama when talking about the 2008 crisis, is we should never waste a good crisis. And so this crisis can be used for something. If we can just use the momentum from this huge quarantine block to just stay the course of lowering our CO2 emissions, increase the pedestrian island, reduce our use of CO2 emitting transportation, then we would have a permanent reduction of greenhouse gas, at least from urban areas. And then we would really make a wave, and we could then link that to other positive effects, the reduction in urban smog, the reduction to our vulnerability to COVID. Also, because COVID is probably going to come back. Now, the assumption is that it's going to come back in a time when we are ready for it. So we'll be in much better shape. And one of the ways in which we'll be in much better shape is we will have cities where levels of smog are far lower.
So do you think, actually, in the post-COVID world, do you have any reason to be optimistic or encourage that government leaders will consult scientists like you when they're making their future plans? You know, are they learning that the experts are actually very helpful here? And
so there's two levels of consultation here. So I've been in the business of climate change for 30 years. So I have different expectations of being consulted by governments. And I've gone through different phases. There were phases where in the early 90s, when the first IPCC report came out, we were just a bunch of lunatics. So we were never consulted, and the sort of the very, very powerful fossil fuel lobbies were very combative, and they just said, no, climate change, there's no consensus, it's false, go play with some other toys. And during that time, in the last 30 years, we've had favorable and unfavorable governments in all countries. You've had, in all countries, you've had governments that recognize climate change and governments that didn't recognize climate change. And 30 years have passed. And in those 30 years, regardless of whether you had a pro or a helpful or unhelpful government, in 30 years, the language has changed drastically. And so for example, just to give you an example, BP is no longer talking about global warming not being a thing. It's talking about how BP can help the process, how BP can produce, can keep on pumping oil, but having a smaller impact. So they're still trying to maintain their footprint, absolutely, but the language has changed. So I find there are two levels of discussion between government and scientists. So there's government talking directly to scientists, and that happens through the IPCC, that happens through the assessment reports that we publish every 7 years. The last one came out in 2014, the next one will come out in 2021. And that's been going on since 1992. And there are branches of the government that talk to us all the time. But that's not every branch of the government.
Every government.
Sort of the branches,
yeah.
Right. Nor every government, but many governments, though, they won't talk directly to scientists. And frankly, why would you? We're just boring. We're just boring and factual. And I wouldn't talk to me, so I understand nobody else would want to. But they talk to activists. And what we have now, what we see more and more, is we have informed, intelligent activists. So the activists in the 90s, or the activists, the environmental activists in the 70s that would paint themselves green, wear flowers, and go have a picnic in the field, those weren't very helpful. But the activists today that talk in terms of carbon footprints, that talk in terms of carbon, know what carbon sequestration is. They know what fossil fuels do. They know how dirty coal is relative to natural gas, relative to oil. They know those things. They know what CO is compared to NO2, compared to CO2. They know what methane is, and they know the sources. Those activists are much more useful in talking to those governments that talk to those governments that talk to the parties that talk to constituents. So if you can get to the constituents, and that's where activism is really, really important. And there's an intelligent activist, there's an online activist, there's a young activism that is beyond that really helps people like me. I don't know how to do that. We're not good. We have the numbers. So when we're asked a question, when we're asked questions like, but are you sure? I say, well, of course I'm not sure. I'm a scientist. If I was sure, I wouldn't be in the job I am. Most of my research in the last 20 years is trying to find out how unsure we are. That's what I do. My field is bias correction, which a lot of it has to do is actually figuring out how unsure I am. So if you ask me if I'm sure, of course I'm not. Let me tell you how unsure I am. But that language doesn't come across well. And so there you need activists, because there are a lot of things that we are sure about. So we're definitely sure that anthropogenic greenhouse gases are the cause of observed climate change associated with global warming. We're absolutely sure about that. There's no doubt. What we have concerns about is how they're going to impact us. And by how, I mean how much. Yeah? So it's different levels of panic is where the uncertainty lies.
So I would like to suggest that you are a scientist, but you are also training new scientists and new activists, and that AUP is the perfect platform for combining scientific information with the ability to communicate and encourage and educate other people. We're creating those activists you just discussed, who are young, committed people passionate about changing human behavior by educating others. So So thank you for that. And
So
I
this
have
is,
one final comment. So you make one, and then I have a closing comment from one of our board members.
okay.
No, you go.
Oh, okay, I go. So yeah, so here's what I talk about a liberal arts education. That's the extraordinary value of a liberal arts education. When we have people who double major in communications and quantitative environmental science, my first student, Anya Verkamp, that I adore, graduated some 7 years ago and then went to work in Indonesia as the communications director, the online communications director for a logging company. And she was really, really following closely and concerned with the environmental impact of that logging company. After 3 years in Indonesia, she went back to Brussels and is now doing a PhD in Barcelona. So this is the kind of extraordinary professional life that our liberal arts students have, because they marry this ability to communicate and desire to communicate and drive to communicate with a scientific education. One of the things that one of our professors in environmental ethics says, your overriding responsibility, your ethical responsibility as a responsible environmental activist is to educate yourself. Principally, know the facts and then move on and communicate. But it's just know the facts. That's your first responsibility. And it is extraordinary. It's an extraordinary resource we have at AUP that we can marry these two drivers. We can marry these two desires in our students.
It's great. Well, we've come to the end of our hour, and I'm going to read one final comment from Achim Kluber, one of our board members who had to sign off a few minutes early for another meeting. And I think he really sums it up so beautifully when he says this. And they say that globalization is dead. Not true at all. We have an Italian descent, and I think also Peruvian, professor at AUP engaging people on this call in France, Germany, the US, and all over the planet on a topic that is so deeply important to all of us in this moment. I think, what have we learned from this? This brings our AUP global community together, and it isn't wonderful. So I would like to thank you, Claudio, and everyone on this call for participating. We have a little virtual hand clap. We haven't quite, that's the only piece of the technology we haven't quite worked out yet, which is to say, a big round of virtual applause, please, for this wonderful professor sharing an hour of his time with us.